You've probably all experienced this. You feed an LLM tens of thousands of words, and it starts hallucinating, or even forgets your original instructions. Today, we are going to uncover the truth behind this phenomenon. Many people think the bigger the context window, the better. But the reality is that the underlying math of transformers dictates that the more data there is, the easier it is for the model to get lost. This is what we call context decay. To solve this problem, we need a paradigm shift in how we think. We absolutely cannot just stay stuck at the level of how to write a good prompt. You see, prompt engineering is like teaching someone how to speak, whereas context engineering is building them an office, defining where files go and how to look up historical records. It's a shift towards systems-level thinking. Since we're building an office, we first need to figure out what kind of filing cabinets the agent actually needs. Memory is absolutely not just a single flat chip. Think of these four zones like the human brain. You have working memory for immediate calculations, episodic memory for recalling the past, semantic memory for remembering facts, and procedural memory, which is like muscle memory. They each have their own job. Many developers think that plugging in a knowledge base is the same as giving an agent memory. That is completely wrong. Before we move on to the next part, let's do a quick pop quiz. Take a moment to think about it. When building agents, this is the easiest pitfall to stumble into. Which one do you choose? Lock in your answer before we move on. If you got it right, it means you understand the essence of state management. So, what happens to the system when the memory keeps piling up? The next slide will reveal the answer. When we stuff all kinds of memory and tool outputs into the agent's brain, disaster strikes. We have to learn how to deal with context decay. It's just like having 100 tabs open in your browser. Not only can you not find what you want, but your computer freezes up. AI is the same way. It gets distracted and can even be poisoned by bad information. How do top-tier engineers solve this? They use these 4 moves: compress right before maxing out, have the AI take its own notes, only load data when needed, and strictly stratify the context. Look at this pseudocode. Don't just dump all your data in at once. Give the agent a directory and let it decide when to read which file, and once it's done, have it write the conclusions in its notes. This is what we call active memory. Even if you manage context perfectly, a single model still has limits to its capabilities. When you hit that wall, you have to pivot to a multi-agent system. If you make one person act as the architect, programmer, tester, and product manager all at once, they will definitely break down. Once you introduce multiple agents, you have to decide how much freedom to give them. It ranges from a completely free-form chat mode to a workflow mode as strict as a factory assembly line. Choose based on your tolerance for error. So, what level is your team at right now? The industry has mapped out a 4-tier maturity model. But how is it applied in real-world scenarios? Let's take a look. Most people are still stuck at the bottom level, obsessing over prompts. True masters build information flows at the 2nd level, design agent intents and goals at the 3rd level, and ultimately achieve enterprise-scale standardization at the 4th. Imagine your system is about to crash in a production environment. What would you do? Take 2 seconds to choose. Clearing it entirely loses state. And infinitely expanding the window is not only exorbitantly expensive, but also prone to distraction. Compaction is the enterprise-grade approach. So, where do these compressed memories actually live? Memory can't just exist in a vacuum. A top-tier context engineer must know how to choose the right database for different types of memory. Stop relying exclusively on vector databases. Use relational databases for user profiles, KB stores for session states, and graph databases for complex relationships. Prescribe the right medicine for the right type of memory. When you have multiple agents, a pile of tools, and complex databases, how do you know which combination works best? Gut feeling? Exploration is like trying your luck at a restaurant you've never been to, while exploitation is ordering the signature dish at your usual spot. Bayesian optimization and the UCB algorithm help you find the optimal architecture in this endless configuration space with the fewest possible tests. The architecture is built, and the parameters are tuned. But how do you prove to your boss that your multi-agent system actually works? A good system shouldn't just deliver the right final result. You also have to look at whether its planning makes sense, whether its experts are highly capable, and whether the team works well together. All four of these dimensions are indispensable. Don't use the same exam for everyone. Use RAGAS to test retrieval and Spider to test SQL writing. Only precise yardsticks can measure true capability boundaries. We've covered a lot of ground, so let's quickly recap the most crucial, hard-hitting concepts from today. I recommend taking a screenshot of this. These 5 terms form the cornerstone of modern agent architecture. Understand them, and you understand the underlying logic of future AI systems. This is the most important sentence of the day. Prompts determine the floor of your AI, but context architecture determines the ceiling. Don't be tactically diligent, but strategically lazy. Times have changed. We're moving from lone wolf operations to army-level coordination, and from stuffed contexts to precise memory management. This isn't just a technical upgrade, it's a paradigm shift in how we think. Go back and look at your code. Delete those hard-coded, insanely long prompts. Introduce JIT, introduce tiered context, introduce long-term memory for your agents. Go build a truly intelligent system.